I'm delighted to be joined today by Dr. Heinz Ossenbrink. He's head of the Renewable Energy Unit at the European Union, and he's also the conference chair here at EUPVSEC. Welcome, Dr. Ossenbrink.
Thank you.
Okay. Now, can you give us an overview of what's happening at the conference this year, some of the key topics that are being discussed and matters that are...
Well, I'm chairing basically the scientific program, so we have scientists around the world showing the latest results of the last year's R&D, and we traditionally separate this into very advanced studies and topics where you can listen to highest efficiency records like 42% solar cell efficiency, but also what the organic cells, how they're coming up and finding their market. There's a lot of progress reported. We have certainly many of scientific presentations on everything what is silicon, from raw material production of improvements of yield, of throughputs in wafering and solar cell manufacturing, but also getting the most out in efficiency, in particular then already on the module size. So we have back contact cells with high efficiency. We have here record efficiencies on multicrystalline modules. I think it's at the moment 18.7% on a module level, which you can buy actually. We have the topic on the variety of thin films, in particular CIS modules are taking up more and more market share. They're more mature. They're running. They have to develop their own manufacturing equipment, different from the most distributed thin film technology, cadmium telluride, but also microcrystalline tandem structure. Getting more and more stabilized efficiencies at a very high two-digit range, so 12%, 11%, really on a large module size. Then what certainly Europe is a leader in, how to integrate everything, how to get the balance of system costs down. Europe is a leader because it has the largest installation base. More than 75% of PV installations are in Europe. And there you see how much brain goes already to optimize these processes, to get it at the end in the field or into the building, up to how do we optimize cabling, how do we make fault-tolerant PV arrays that we avoid that the power goes down only a single module fails. So how much of intelligence I can put, and that's all reported here, and it's pretty exciting.
Right. Yeah, there's a huge number of challenging technologies and new things happening in the market. But one of the key things that has certainly been featured certainly on the show floor this year has been the methods, ways to drive cost out, especially with these special metals, the precious metals such as silver, indium, etc.
But I would say this shows only how mature in the meantime the whole industry is. That you see, very often in the public you read, there will be difficulties because you don't have enough material for photovoltaics and so on. My perspective also for this conference is photovoltaics has still so many options. So if you have one problem with the material, you will have enough R&D maybe to replace it or to optimize it, to reduce the material consumption, but still keeping the same, or to replace it with others. The photovoltaics has so many options that I used to tell it's in principle a low-risk future technology because it has so many options. It's not depending on one single issue. So if somebody would tell you, forget this technology because this material like indium, you have only this and this available, they will find replacements. So physics gives us fortunately so many options still to make semiconductors that nobody is really feared. Certainly then there might be shifts that for a certain period you get more from this material. But I remember there years ago when everybody talked about silicon crisis because there's not enough electronic grade silicon. Markets are very intelligent. Important is that there is an end drive from really application market. So if there is a market, people have a reason to do more research in solving the problems and getting costs down. Otherwise it would be a science affair as on its own for the sake of publications. And this is exactly not the case at photovoltaics.
Now, wearing your European hat for a moment as head of the Renewable Energy Division, what do you see as being the future for PV in Europe?
Well, at the moment, we just look in what the European Renewable Energy Directive, which is now transposed into member state laws, which foresees mandatory targets to be achieved by 2020. And one of the features of this directive is that the member states have to hand in an action plan on renewable energy. So they get an overall target. How they fill it out, they had now to describe in their own action plans. How much wind, how much photovoltaics, how much biomass, by when. In particular, on which trajectory in the next 8-9 years. We have all these plans, and analyzing how much the member states commit already mandatorily for photovoltaics, we arrive with 86 or 88 gigawatts by 2020. So compared to what we have now installed, another 50 or 55 additional gigawatts. So this is the minimum, which is not only a promise, they have to do it. It's binding. It's as if you would say...
Mandatory.
It's mandatory. Yeah? And now already this market alone ensures for Europe a very stable market. It might well be that we don't get the same growth rates as we had in the past, but there's stability. And my guess is by 2020 we have such a mature photovoltaic energy system that it probably runs on its own. Now another aspect is, as everybody talks about crises and so on, we had in the opening session the Greek Minister for Environment and Climate Change. He is proposing in this particular difficult situation in Greece to invest in photovoltaics in Greece, to export solar energy, they have a lot of sun as we know, in order to get out of the crisis. So rather than